Bienvenidos, Ushamadid, and welcome UMGC learners from CMIT-455, Section 6380 for the Spring 2021 semester. This is the Cisco Networking Academy CCNP ENCOR version 8 curriculum, and in this video tutorial, we're going to be taking another look at virtual routing and forwarding. Specifically, we're going to be using VRF-Lite. Now, this part 2 is going to focus on configuring VRF-Lite in the environment in which we were previously working. And as you can see here, we've already in part 1 configured the VRF configuration stanzas for both router 1 and router 2, and we're dedicating individual physical links between router 1 and router 2 for VRF red, blue, and green respectively. Now, remember, we took a look at this image here in order to sort of drive home the idea that what virtual routing and forwarding is allowing us to do is to segment or separate traffic on the same physical router. Just like each of the lanes that we have here in this image is separating each of the individuals sliding down the slide. It's the same slide, but everyone is in their own mutually exclusive individual lane, and that is how they are going to be traveling. So if we look back at our image here, we can see that the VRF is a locally significant defined concept. So over here on router 1, we have VRF red, blue, and green, and it's the interface that belongs to the VRF. So on router 2, I don't have to say red, blue, green. I could say VRF 1, 2, 3, and then use those as the VRF names. Now, just like with sub-interfaces, where the sub-interface number, like gig00.10 or .20 or .30, doesn't have to match the VLAN for the traffic that it is servicing, you would be crazy not to do it like that. Again, think big picture, long term. If you have to troubleshoot that configuration, it's going to be much easier if you're able to look at the interfaces just like we have right here and say, oh, gig 3.10, well, that must be ultimately for the VLAN 10 network over here, which we're simulating with a loopback interface. But you should get the idea that if you can keep these values the same, that's exactly what you would want to do. So the first thing we're going to do, which is the last thing I forgot to do in the previous video, is we are going to upgrade router 1's legacy IPv4 only VRF configuration, and we're going to make that an address family configuration. In other words, a multi-address family configuration where it could support IPv4 and IPv6. And again, if you're configuring or starting from ground zero, this is definitely the configuration syntax you would want to use. You saw that we did that on router 2 with VRF definition and then VRF forwarding under the interface. On router 1, and let's jump over to router 1 here, and here we are on router 1, and you can see the router's just booted up this morning, and we've got all of our Ospf adjacencies. And so here, if I was to say show run include VRF, you could see that we're using this legacy syntax here. IPVRF blue, IPVRF. And by saying IP, what we're saying is IPv4 only. And so we want to fix that. If I come over to router 2, let's take a look at that configuration with the VRF definition. Show run include VRF. And you can see here it's VRF definition. This is the address family approach. And you're going to start to get the sense that a lot of things follow this address family approach. Ospf v3, we can use address families. BGP, we can use address families. EIGRP, we can use address families. And so you kind of start to get the idea that this is, as they say in The Mandalorian, this is the way. And so this is the way you're going to want to do it. But if you had a legacy configuration, the only thing that you would need to do in order to uplift this configuration is say VRF Upgrade CLI multi-AF mode, which is exactly what we want. And you'll notice that here we have two options: common policies. And what that means is if I had route target policies applied, that I would apply these to both IPv4 and the multi-address family configuration for IPv4 and IPv6. If I say non-common policies, what I'm saying is that these are not moved to the common VRF policies area. In other words, the policies, route target policies, would not be applicable to both address families. Here, they're going to get moved into the common policy section so that it impacts both address families. Non-common means don't move those. Keep them in the IPv4 VRF address family configuration stanza. And so I don't have any policies configured. Again, kind of a moot point when we're using VRF-Lite and we're not using route targets. But I will go ahead and say common policies. It asks, are you sure you want to upgrade? And this is a hitless operation. Again, think of that as the VRF Upgrade CLI multi-AF mode. Think of it as a macro. And behind the scenes, it's just simply shuffling around the statements that we have. So now when I say do show run include VRF, we now have VRF definition blue, VRF definition green. You'll notice none of the OSPF adjacencies went down. We didn't lose connectivity between router 1 and router 2. All we did was sort of change the syntax to what I like to call the multi-address family mode syntax. And again, going forward, this is how you should be doing it, not with the IPVRF. Again, we saw in yesterday's video where it will actually tell you, if I say do show VRF detail, it will actually tell you whether you are using the new CLI format or if you're using the old CLI format. So you definitely want to get in the habit of using the address families. So we've performed that. I apologize for leaving that out of the other video after saying that I was going to put that in there. But here it is right out of the gate with an explanation as to what the common policies is all about and the non-common policies is all about. So we've saved our configuration on router 1. Let's take a look at router 2 here and let's check. Can I ping VRF red to the 10.111? And let's see, do we have connectivity? We do. What about a ping? Oops, sorry. What about a ping VRF blue over to the 10.2.2.1? Again, router 1, that simulated LAN network. We could say that, you know, imagine that that is VLAN 20, the VRF blue, and that VRF red is VLAN 10. And let's make sure that everything's working here. 331. Oops, sorry. And we want to say VRF green, 10.3.3.1. And we have connectivity there. So where does our focus turn now? Well, now we're going to take a look at our next use case. So the use case for VRF-Lite here was that we had 3 physical interfaces, each physical interface dedicated to a VRF. And that's one way to do it. Now, maybe you don't have, and I'm hovering over router 8 here, maybe we need connectivity between router 2 and router 8 for all 3 of the VRFs. However, router 8 only has, or we only want to allocate this single Ethernet interface, right? Maybe that's the last Ethernet interface available. We've got the serial interface on the back end here, but here, between router 2 and router 8, we only have these 2 interfaces. And on a 3945E without any expansion cards, by default, you get 4 gigabit Ethernet interfaces, gig 00, 1, 2, and 3. So this router 2 is out of interfaces after I use 3. So I want to be judicious. I don't have 3 more physical interfaces to dedicate here. And so how are we going to do this? we're simply going to do what you've actually already seen. And that is that router on a stick sub-interface configuration that we did. And that's really what we're doing here. We're going to be, just like VRF allows us to carve up a physical router into multiple logical virtual routers, I can carve up a single physical interface into multiple sub-interfaces. And the analogy holds true when we continue with it to say that just like all of the virtual routers with their own ribs and their own fibs and their own interfaces, on router 2 and router 1, all of those VRFs are sharing the physical memory and physical CPU constraints on these routers. And that analogy holds true with this sub-interface, is it's a single physical interface that we're going to virtualize by creating sub-interfaces. And those sub-interfaces are all sharing the throughput of that single physical port. And so here they're all sharing, a gigabit a second, and you can see we have a mismatch, right? So we're only going to be getting 100 megabits a second tops because we're limited by our slowest link here, this fast Ethernet 01. But again, hopefully you see that the port is also sharing. It's not as if I just created 3 independent gigabit Ethernet interfaces or fast Ethernet interfaces. That's not what we're doing. We're taking that gigabit Ethernet interface and we're carving it up into 3 virtual interfaces, sub-interfaces, and the same on the fast Ethernet side. And so this again is a use case where you would have to consider, if I have 3 sub-interfaces here, am I going to be able to support that amount of traffic? Because if I've got 100 PCs that are back on this side that are trying to get over here, and they all have gigabit Ethernet interfaces, this may be a bottleneck. And if this isn't the bottleneck, the serial interface will probably be your bottleneck. Again, things to think about when you're thinking about putting the network together. So let's dive into the command line. And this again is going to be very straightforward. It's going to be between router 2 and router 8. On router 2, we have already created the VRFs. So let's jump on to router 2. And we are actually already here. We'll get into global config and let's say do show run VRF. And this is another way to see your VRF configuration. And so I can take a look at this and see we've got VRF blue, and there are the address families that I talked about. And you can see VRF forwarding blue on the interfaces gig 01, gig 01. And then we've got the green VRF. Actually, I just skidded right by it there. The green VRF with all of the green VRF information, followed by the red VRF. And this is doing it in alphabetical order as well, if you didn't notice that. Blue, green, red. And so it shows me everything that these VRFs are involved in. So let's go ahead and say do show IP interface brief. And we can see that we have that gigabit Ethernet 03 interface. So let's get into interface gigabit Ethernet 03. And let's say no shut. Again, we want to bring the parent interface up. That way, all the sub interfaces that we're about to create are also going to be up. Now, what I could do is come over here to router 8 because I believe fast Ethernet 01 show IP interface brief. I believe fast Ethernet 01 is shut down. So if we came into global config, interface fast Ethernet 01, and I say no shut, we should see that that interface comes up. And then over here on router 2, excuse me, we should also see that the line protocol comes up. The reason that that message came up, that the link was up down, was because gig 03 was up, but on the opposite side, on router 8, fast Ethernet 01 was administratively down. So now we've addressed that issue. That way we're going to see all of these links come up as we create them. So let's go into interface gigabit Ethernet 03 dot, and we're going to stick with the 10, 20, 30. Again, we're kind of pretending that over behind router 1, those loopback addresses are actually maybe links into a 48-port switch or a 24-port switch, and VLAN 10 is the access port between the switch and the router, right? Or maybe we're doing router on a stick over there, right? So we'll say interface gigabit Ethernet 03.10. Now remember, I can't put the IP address on. I cannot do this, 169.254, and I'm showing you this just so that you see that we're going to get an error here. And if I was to make it a /24, it's going to come up and say, hey, remember, you're partitioning, segmenting this physical interface. So you need to tell, excuse me, you need to tell me, gigabit Ethernet 03.10, which traffic is it that's going to be coming in on this physical link? Which traffic am I responsible for? And here's where those 802.1q tags are going to come into play. And so on router 2, I would say incap.1q 10. Then I can put the IP address on there. Now we're going to go into interface gigabit Ethernet 03.20. We're going to say incap.1q 10. Oh, sorry, hold on one second. I'm sorry, incap.1q20. I looked at that error and I was like, wait a second, why am I using 10? So incap.1q20, and remember, we can use the same interface, but what do we have, I'm sorry, the same IP, but what do we have to do first? And again, doing that so that you can see, what did we forget? Well, yeah, we forgot that in interface gigabit Ethernet 03.10, I want to say VRF forwarding red, right? And what does that do? Well, that removes the IP address. So let's put the IP address back on there. Let's say do show run int gigabit Ethernet 03.10. Now that's the configuration that we're looking for. So let's go into interface gigabit Ethernet 03, 0/3.20, and say do show run gigabit Ethernet 03.20. We've got our incap statement. Before we put the IP address on here, right, what do we want to do? We want to say VRF forwarding and then blue. Then we can pull that IP address command up and apply it, because we can have the same IP address on multiple interfaces as long as we have them in their own VRF. And remember, an interface, a sub-interface, an SVI can only belong to a single VRF. All right, so that should take care of do show run int gi 03.20, and that should take care of that interface. And so interface gigabit Ethernet 03.30, and again, incap.1q 30, VRF forwarding for green, and then I can just go and pull the IP address command back up, and there we go. So let's say do show IP interface brief, and let's see what we've got here. All right, so we've got our physical interfaces that are all in VRFs, all with the same IP, because again, there's no need to try to come up with some sort of subnetting scheme or something like that where, you know, gig 00 uses one subnet, gig 01 uses another. You can do that. There's nothing wrong with that. But if they're in VRFs, we can use the same IP addresses. And we've just done that for these sub interfaces right here. So let's take a look at the diagram one more time, and you can see gigabit Ethernet 03 has been divvied up for VRF red, VRF blue, and VRF green. Remember, the VRF is locally significant. Could I use different names along the way here on every router along the way? I certainly can, as long as the interfaces that I need for red or for blue or for green are in the right VRFs. We're going to be just fine. So now let's come over to router 8 and let's do router 8's configuration. Remember, the loopback interface on router 2, that was all done in the previous video. So now we come over to router 8 where we're going to carve up fast Ethernet 01. So we jump on to router 8 here, interface fast Ethernet 01.10. Now, what's the problem going to be here? So what if I say VRF forwarding red? Yeah, the VRF isn't configured. So this, again, is a manual thing that you're going to have to do step by step, router by router, is to configure VRF definition red. Now, remember, I need to say address family IPv4, and the unicast is implied, and that's it. And now for VRF-Lite, I'm ready to go for VRF red. But let's go ahead and pull up and do VRF blue, and then we can just up arrow ourselves here, and we'll say VRF green, and then up arrow for the address family IPv4, and then we say end. Say show VRF, and we'll see what interfaces are involved, what protocols are defined. Again, we're not doing IPv6, so no need to do the address family for IPv6. So we've got blue, we've got green, we've got red. No route distinguisher. Again, remember, the route distinguisher is something that's related to MPLS and specifically multi-protocol BGP. So now let's get into global config, interface fast Ethernet 0.1.10. I can say encap.1q10 because remember, on either side of this link, these sub-interfaces between router 2 and router 8, because we're doing sub-interfaces, they need to know which traffic with the 802.1q VLAN tag they're going to be servicing on which interface. And then again, we've put that interface into the VRF. That's going to give us that end-to-end connectivity. So encap.1q10 VRF forwarding for red. So now let's throw our IP address on here, 169.254.28, because it's between router 2 and router 8, and this is router 8. So 255.255.0. So what if I was to say do ping VRF red to the 169.254.28.2? Do I have connectivity over to router 2? We've got an ARP, and then check it out. We've got connectivity. So let's get into interface. Fast Ethernet 0.1.20. And we're going to say VRF forwarding blue. We're going to say encap.1q20. And then we're going to say IP, and actually we could just up arrow to the IP. We're going to use the same IP. Why not? Oh, sorry. We're going to use the same IP. Why not? Because they're all in their own individual VRF. They are not in the global VRF, which I like to refer to as the global context. They're not in the global routing context. Remember, do show IP route shows me the global routing context. Do show IP route VRF red is going to show me the routing context for VRF red, just like do show IP route VRF blue will show me the routing context for blue. And we see that subinterface .20 in there. So now let's go into interface fast Ethernet 0.1.30. We're going to say encap.1q30. We're going to say VRF forwarding green. And then I think I may have just done this, but let's pull it back up and put the IP address on here. So now do show IP interface brief. There we go. So everything looks good there. Now, what are we missing? Remember, in order to test connectivity, we want to make sure we have loopback 1, 2, and 3, and they're all going to be the same host route /32 for the all 8s for router 8. That way in VRF red and blue and green, we can test and see after Ospf is configured, can I reach destinations over here on router 1 and beyond to these network segments. And again, like I was saying, if you think about this, you could have, this could be router on a stick over here. But again, I did individual. So maybe this is an an Ethernet interface expansion card, goes to a switch that's for this VLAN. You could do router on a stick here, right? You could have one Ethernet interface goes to a switch, and we just simply do router on a stick with the .1q tags. And so hopefully you're starting to see the use cases for the 802.1q tagging, right? Because we're basically doing router on a stick here, in a sense, right? There's no switch on the other side. It's a router on the other side, but it's the same configuration approach where we create sub-interfaces, we tag those interfaces with an 802.1q tag that theoretically corresponds to this VLAN that we would be working with, or VLANs that we're working with, and that allows the traffic to flow. So let's knock out these loopback interfaces. So interface loopback 1, we're going to say VRF forwarding red, and then we're going to say IP address 8.8.8.8, and we're going to make it a /32. Right? So now that interface is actually up. So now I'm going to say VRF blue, and we just hit the up arrow, oops, sorry, and we'll say because right now blue is in the global routing context. So VRF forwarding blue, now it's in the blue VRF. And then we're going to say, what are we doing here? Interface loopback 3, and this is going to be a VRF forwarding for green. And then we're going to say the IP address of the all 8. So now do show IP interface brief. And we should see we've got these 3 loopbacks. And again, loopback 2, the address was probably removed. Loopback 2, and let's get that address back up there. And there we go. So we'll say do show IP interface brief. And now we should see that. And let me check do show run interface loopback 2. Let's just make sure that VRF statement got on there. And it's a good thing we went back and looked at that. VRF forwarding blue. And now, okay, so I must have typoed it, and then it got rid of the IP. And so now we're going to put on, hold on one second here. Do show VRF. I may have gotten myself into trouble. So, so loopback 1, I put in the wrong VRF. Okay, so here's what we're going to have to do. We're going to go to loopback 1. VRF forwarding is going to be red, right? And so then we'll put the IP back on here for VRF 1 is red. And then we'll go into interface loopback 2. VRF forwarding is blue. Even though it says it there, I'm just going to rerun this just to make sure. And that is why we didn't see it remove the address previously. So now we've got the right IP there. And then do show run int loopback 3. And there we go. All right. So now we've got the loopbacks configured. The only thing that we have left in our configuration now is let's configure Ospf here on router 8, just like we did on router 2. And so how do we do that? We say router Ospf 1 VRF red, and let's make sure we get the right VRF for the right Ospf process ID. And the first thing I'm going to say is router ID is going to be 0. And so here's where we're going to run into a challenge, but let's do this. 0.0.0.8 for the first router ID. We'll say passive interface default, no passive interface, gigabit Ethernet 0, fast Ethernet interface 01.10. Now let's add the network statements in for the 8888 with the all zeros wildcard mask in area 0. And then we'll add in the network statement for the 169.254.28.8 interface in area 0. Now, we are not going to see the adjacency come up yet. And the reason for that is because the configuration on router 2 for these adjacencies between router 2 and router 8 has not been done. So now let's go ahead and continue router Ospf 2 VRF blue. We're going to say router ID, and here's how I'm going to handle 8.88. Right? Or I'm sorry, we'll just do 88 for VRF2, and then we'll do 8.88 for the last one. We'll say passive interface default, no passive interface, fast Ethernet 01.20, and then we'll add our network statements in. So we'll add in for the 8 network here in area 0, and we'll add in for the transit interface, the 169.254.28.8 with a quad 0 wildcard mask in area 0. Router Ospf 3 VRF green. The router ID will go with 0.0.8.88, so the 3 8s there. And then we'll say passive interface default, no passive interface. Passive interface default, no passive interface for fast Ethernet 01.30. And then let's add our network statements in here for the all, and in fact, we could just go up arrow to get that stuff done. So because all the IPs are the same. And so this is another benefit of when using the VRFs is just go ahead and use those same IPs for your transit segments. Makes it a little easier to configure. All right, so on router 8, we're going to write mem, we're going to save our config, and we're going to come over here to router 2. Because remember, on the router 2 side of the house, show run section router Ospf VRF red, I'm sorry, I wanted to do just Ospf. Ospf, you can see we've got our red VRF configuration, but we don't have that network statement for the 169.254.28.2. And so let's do that for each of the three VRFs. So we're going to go into router OSPF 1 VRF red, and we're going to say network 169.254.28.2. We'll do a quad zeros and area 0, and we'll hit enter. And what we should see happen here is the adjacency within the next 10 or so seconds should come up. And while we're waiting for that, we'll say router OSPF 2 VRF blue, and then we'll run that same network command, and then I'm also going to say no passive interface gigabit Ethernet 03.20. So as I was configuring VRF blue, I'm like, why is the red VRF adjacency with OSPF not coming up after about 10 seconds? And it's because we left the interface passive. So I would want to go back in and say, and there we go. So blue comes up without any issues. So router OSPF 1 VRF red, let's say no passive interface, gigabit Ethernet 03.10. And now that will come up within the next 10 seconds, and right away we get that adjacency. So now I'm going to say router OSPF 3 VRF green. And again, no passive interface, gigabit Ethernet 03.30, and then that network statement that we're looking for that we already had teed up. So we'll say end. We should see that adjacency pop up here in just a second. And we'll wait for the configuration to finish writing, and there it is. So show IP OSPF neighbor. Let's see what we've got. So there's a list of all of my neighbors, and you can see it's easy to tell here who's router 1 and who's router 8. And you can see that we've got DR BDR elections taking place on all of our links because these are broadcast network types, because these are Ethernet multi-access, right? Remember that. And so we have that DR BDR election. And then here's all of our sub-interfaces. So let's come over to router 8, right? We want to come to the far end of things here for right now and say, show IP OSPF neighbor. What does router 8 see? Sees all of its adjacencies with router 2. What about a show IP route OSPF? Well, I don't see anything. Why am I not seeing anything? Again, trick question. Yeah, well, remember, in the global routing context, I don't have anything configured in the global routing context, but if I say show IP route VRF red, if I say show IP route VRF red, I had the OSPF in there, sorry about that. So if I say show IP route VRF red, now take a look. I see the loopback for VRF red on router 1. I see the loopback for VRF red on router 2. So if that's the case, I should be able to say, and let's give this a try, ping VRF red 1.1.1.1. And take a look at that. I've got reachability all the way out and behind that router 1, or to router 1. And then let's check out, can I get to that simulated network out there? Absolutely. Can I hit the blue VRF and the 2222? And so let's see, VRF blue, router 2, 2222. And yes, I can get to router 2, and that works like a champ. What about the 10.2.2.2? Remember, that's the global routing context. I'd have to say ping VRF blue 10.2.2.2. Again, just showing you that if you're not in the right routing context, I'm sorry, it's 2.1 now that I hit the too many twos there, because it's over behind router 1. And there we go. So ping VRF green 10.3.3.1 because it's over behind router 1. And take a look at that. We've got reachability. So we've now moved to this segment here, fully configured it, so we have reachability from router 8 to all of these networks that are behind, theoretically, right? We're simulating with loopbacks, but that theoretically could be hanging off of router 1. And we've done all of this by segmenting and segregating all of the traffic for each of the VRFs into its own routing table, its own forwarding table with its own interfaces or sub-interfaces. And so tomorrow, we're going to take the next step, and we're going to do back-to-back frame relay sub-interfaces using DLCIs between router 8 and router 9, and we're going to extend those VRFs one step further. All right, well, that is going to wrap up part 2 of this 5-part supplemental tutorial series where we needed to have a little bit more conversation around virtual routing and forwarding, and most importantly, the use cases for where it becomes very, very advantageous to be doing VRF Lite. All right, thank you so much for watching, and I hope to see you in the next video.